Hello, welcome to the bound theorem. So if we have a P series, with P greater than 1, that P series is going to be bounded between 1 plus 1 over P minus 1 and 1 over P minus 1. So here is a P series. So we have P is equal to 3, which is greater than 1. That means this series is going to be bounded. So we bound it as follow: k equals to 1 up to infinity 1 over k raised to the power of 3 less than or equals to 1 plus 1 over 3 minus 1, and then on the lower bound it's going to be 1 over 3 minus 1. It's going to be bounded between 1/2 1 over k raised to the power of 3 bounded between 3 over 2. The other series, let's call it ace of n. So this series here I have p equals to pi greater than 1. That means ace of n, right? Summation from so ace of k at this point, k equals to 1 up to infinity of ace of k. It's going to be bounded between 1 plus 1 minus pi minus 1 and then 1 over pi minus 1. Okay, so this is a theorem. If we consider ace of k, where ace of k here is greater than 0 for all positive integers k, suppose that f is continuous, positive, and decreasing function on the interval 1 up to infinity. So ace of k is going to be equals to f of k for all positive integers k. The improper integral from 1 to positive infinity of f of x dx that converges, then the sum of the series bounded. So the sum of the series would be bounded by these. So ace of k is going to be bounded by the result of that integral plus a, which is like the first term. This would be the upper bound, or the lower bound is going to be integral from 1 to infinity of f of x dx. All right, that concludes today's lecture.